Hi, welcome to this class. Now, in this class, we'll be looking at how to filter aggregates in SQL. Um, Initially, in the beginner level course, we kind of had a view of how to filter a data set, but we never really looked at how we could filter, based on an aggregate logic. So, what is an aggregate logic? Now, we have this type of data set, right? So we have a data set where we have different orders that was made. Different sales that was made in maybe in a city, for instance, and then we have different store names that was making these sales. Now, maybe we, as maybe a government body who's trying to, tax um certain stores that had some kind of good sales, maybe differently. So then we will like to know, like which stores had like more sales or maybe a certain threshold. However, because the data set is on, sales level, which means that each row implies one sale and the same store could have like multiple rows, for instance. So we need to sum all the amount that was sold by each store, and then we will be able to filter the stores that basically had like the highest, basically the thresholds that we are looking at. So assuming we're looking at maybe 50 million, so which stores here had a sales of 50 million? So then if we were to go by the beginner level course, I will show you how we will do it and then how it could have been done more efficiently by using the having function. So just let us look at it. So first we have this data set, and then we're trying here to, um, you know, first we're trying to calculate like what is the sum that was sold by each store. Then in the second part, then we try to look at, so we only want the stores that sold above 50 million, right? So here we have, so basically we put the store name, right? And then we are putting sum of sales in dollars, right? Which is actually a column here. So this is the sales in dollars. It's actually a column there. And because we want to see for each store name, so we have to group by store name. Or we can say group by one because the store name is in position one. Now also we have to order by, it's easier for us to order by position two, which is the sum of sales in dollars. But then so basically we just order by this. And this basically helps us to see the stores that sold like the most. So then we can go ahead to filter it. So we call this column sum, total sum sales in dollars. So here now, what is our query doing? Our query is basically selecting the store name and then it's aggregating the sales by the store name because we have decided to group by this. And then it is going to order the table. It's going to sort the table based on this position two because this is position one and this is position two. And then it's going to do it in a descending order, which means you have the highest value on top and then the lowest below. So basically, when we try to run this query now, what we will get here is we will get something like this. But it's kind of strange, right? That we have like store name and then we have some kind of thing that look like a decimal. Actually, this is not a decimal really, but it's just like the result was given in exponential. So one way we could make our result look even much more presentable is to say we will cast this this because it's in the form of the exponential at the moment, but if we cast it as integer, then by the way it's cast is something that has been discussed in another video. You can find it in the description. Now, so when we cast, then we will, when we run the query, so here we have like a much more normal number, which is not exponential. So here we can see that only two items actually had above 50 billion, which is only two stores, right? So this is the way that we could, I mean, do it, but this is not so, it's not giving us exact answer that we want, right? So maybe we can also put this into a subquery and then make it a new table, right? So we could just make it this a new table from, and then come here and see where total sum in dollars is more than 50 million. So what are we doing here now? So what we are doing here basically is we have written this part of the query which represents this table, which basically brings the sum of all the sales in different store names. And then now we want to now select the stores that have above 50 million from this store, because now what we have done is we've made this a new table, just the same way we like the one we had in the database. And then we now make this a new table. But so then we will now filter based on this, right? So we only want to select cases where the store name is above 50 million. So here, I think we haven't put the right amount, or maybe it's 500 million, right? Wait just a moment. Okay, I think there was so here we have only two cases, which is the two stores that is above 50 million. Now, the thing is, when we basically have this, I mean, it's much more complex and it's not as efficient as, we could be. So how could we have done this in a different way? Then now we could have done this by using the halving method. So we will just do this this same query using the halving method, and then we will see our answer after we have done it this way. So now we have our table here. So we want to select from this table. And how would we use the halving method in this case? So we select. So what are we trying to do? We're just basically trying to select the store names, right, that have a sales that is above 50 million. So here we could just, if we want to use the halving, we will just come here and say halving that the sum of sales in dollars is above 50 million. Okay, this is like, I think this is starting. Yes, and also in the halving, we basically have to group by the store name. Now, notice the arrangement of halving. So you have to first select, and then you put the, you select from the store, you select what you want to see from the table, and then you have to group by, right? You have to apply the group by before you put the halving. So you have to first apply the group by, and then it doesn't necessarily mean that you're going to sum. If you want to, you can do any kind of sum computation. But the most important thing is, what are we trying to bring out? So we're trying to see all the store names that have a sales that is above 50 million, right? So here, what are we trying to group by? We're trying to group by store name, because this is what we want to see, the aggregation on. And then we just use the having as a means of filtering the aggregation. So when we run the query now, what do we have? We just have the two stores exactly as we have them in the previous query. Now, if we still wanted to see maybe like the sum of the sales, we could also still include it here. It's totally fine. It's so basically when we run the query, we still see the sum of the total sales. I mean, the same way we could cast this, right? So we could cast it and say as integer. And then also when we run the query, we will see the same thing, right? So here we have the same thing, it's just maybe in a different order, which could have been ordered by. So basically, this is the idea of having. Having makes you write the query, I mean, the filtering, the query that filters data aggregation um, even much more efficiently. So here you have like, like lesser lines of code. It even completes in lesser seconds. I mean, the other one was completed in 1.8 seconds, but this is completed in 0.8 seconds because it's much more efficient. So this is how you could, make your aggregation filtering even much more powerful and efficient. See you in the next one. Thank you.